maybe let's move on to how could we actually develop a product with all this in mind. And what we really like to do with our customers at first is work on their threats and on their assets. And I like to say that one could spend an infinite amount of resources on security. Fact is, no one has an infinite amount of resources. So you have to focus, and you have to focus on what really matters. And there's tools for that. There's a threat assessment, a risk assessment, security targets, and we'll go through all of these. This will help you drive the way you handle security when you develop your product, but also how you handle security during the whole life cycle of the product. So typical security management during development could look like this, starting with a threat and risk assessment, moving on to build and decide on the target of security that you want for your product. And those tools will help you build the architecture for your product. You may want at this point prototype certain concepts or technologies so that just to make sure that the development teams do not hit a roadblock. And then you can move on and develop and obviously evaluate at the end. This all looks very linear. It's actually not. It adapts very well to methodologies like Agile and DevOps. And also, once your product is in the field, you may have to, and you will probably have to come back to at least some of those steps because things change all the time. You might add features, new threats and attacks might pop up, and you will need to deal with those. So on the threat assessments and risk assessments, there are some very good threat modeling methodologies out there. You can just look them up. They all apply maybe to different conditions and different types of products. But in general, it's kind of always the same thing. What you'll want to do is identify your assets. So basically what has value. And we are talking about business value. So for example, the availability of your cloud services, well, that would be probably of high value if your devices in the field actually need connectivity to work. Then you'll want to define the attacker profile. So who are you up against? Are you afraid of the hacker in the bedroom, or are you afraid of nation states? So that's the two opposites. Obviously, in between those, you get a lot of different type of attacker profiles. You have all the insider threats, potentially disgruntled employees, for example. You have cyber criminals. You even have your own competition who might be attacking you. Then you'll want to catalog the potential threats to the assets that you have. So as an example, again, threat against the availability of your cloud services would be or could be ransomware or could be distributed DOS attack. And then you'll want to identify mitigation to those threats. So how do you mitigate the fact that this or that attack can harm you? So these mitigations are what you will likely implement to avoid those threats or at least mitigate them. In the end, one thing that is very good to do to give you a clear view of your risks is to make a risk matrix. So it's basically mapping those threats on a map where you have likelihood of occurrence and where you have impacts. So likelihood of occurrence of, I don't know, DDoS attacks, well, I would say it's medium, that somebody would actually target you with that. Impact could be really bad, especially if it lasts. So you would put impact as high. And then when further down the line, what you'll want is really address all those threats that have high impact and high likelihood of occurrence. Maybe at this point, just a few recommendations. I cannot stress enough that this exercise is actually business-centric. This is not just technical. It does require technical concepts, but you do this for your business. You do this based on the value of your asset, and that's the business value. Also, you should assess the complete system, not just part of it or just the component. At least you should have a threat model for your whole system. Then, if it's an extremely complex system, maybe you'll want to drill down and look into the specific part deeply. But you should really have a complete look at the system. Also, you'll want the outcome to be concrete and actionable. Otherwise, this whole exercise is pointless and it will end up in the drawer. And finally, this is what us technical people often overlook. It's all the non-technical threats. It's everything linked to your logistics. For example, the supply chain, contracts with legal, everything linked to HR. So those things are part of your threat model. You can also, this is kind of a business continuity plan, but for your product. So how do you make the link from those threats and mitigations to developing your actual product and doing the architecture work and the development? Well, the missing link here that we haven't talked about yet is the security target. The security target will detail the level of security you decide to reach for your product. And this is a business decision. This is owned by the product team or whoever is in charge of P&L in your organization. You will want to have the security team help, probably from a technical standpoint as well. And as an outcome, this should be sufficient to drive the design and development teams so that they actually protect your assets that have value appropriately. And appropriately is the key word here, because you'll want to do not too much, but make sure that you have enough security. And in the end, what you do want is make the most out of your investment in security. And this is where the attack classes come into play, because they are organized in a way that they can be used directly to define your security targets. And that's why we went through all this before when we're talking about those classes. They are very helpful to define your security targets. Also, one note that is of importance is you will probably not build your product totally from scratch. You will purchase components, hardware, software, maybe even open source. You will integrate all this in your product, but that also means that all these components that come from the outside have to match with your security target. And finally, that's also at this point where you may want to have a prototyping or design sprint to test some of the concepts of the technologies. For example, if you decide to enable secure boots on your microcontroller, you may want to test that before, see the actual impact of turning that feature on. Make sure that this is going to work out for you in the field. And finally, all that work can also be reused when it's time to evaluate your product. The security target is actually the baseline to define what we call the target of evaluation, or TOE. The TOE is actually what you'll want to test when you perform the evaluation. And the evaluator will test your device and your system against that TOE. And you will pass or you will fail. You'll know at this point if you actually reached targets that you set. And obviously, you will have to deal with all the findings, and maybe you will have to have a couple of rounds with between engineering and evaluation. But eventually, you will end up with a device that is at the level that you want it to be. And again, we talked quite a bit about devices. It's not just about devices; it's about the network. It's also about all the cloud and backend services that you may have. And same goes for everything non-technical. This is stuff that you want people to review, and that's typically all your contracts. That's all the supply chain around your product. Christopher, I think we just scratched the surface of on this topic, but we have more, right?
Yes. Well, thanks, Joel. That was a great overview of the things that we see in our labs. And, you know, the examples that we've shared are things that could essentially happen to any company. And it really requires a great deal of security expertise and awareness and education to find some of these things. And one of the ways that we're trying to help companies achieve that is through IoT Security Workshops. Currently, we're running a 3-day security workshop in Switzerland, and you see the environment here. You saw some of the labs equipment earlier, and this is really to help develop awareness and capability in company using some practical exercises in our labs as well. This is also organizable as an in-company workshop anywhere in the world as well. So if you go to our homepage, Kudelski-IoT.com, you'll see on the first page, there's an opportunity to find out more about the security workshops. And before we get to the Q&A, I'd also like to invite you to look at the resources section in this webinar environment, where you'll be able to download some information that you can take offline and look at, both about the workshop, about our labs, but also some good introductory information to IoT security in general, as well as a white paper that describes in quite a bit more detail exactly the process of threat analysis that Joel just outlined for us. A little bit more about the workshop there, and that said, I'll hand over things back to Jason for the Q&A.
Thanks, gentlemen. That was great. And yeah, let's dive right into questions from the audience. Joel, the first question is for you. What kind of techniques and equipment do you use in your labs, specifically for hardware analysis?
We have, I guess, pretty much the full spectrum. We start with the very simple devices, such as voltage glitchers, and then side channel analysis. One of our specialties is laser glitches. Advanced side channel analysis as well with machine learning, and then we can go all the way to very invasive techniques. We have a scanning electron microscope. We have a focused ion beam. So we can really dig into the silicon and modify stuff there. But obviously, this is not really the kind of tools that we use the most in IoT. What we actually do for IoT is we put a lot of effort into making really cheap attacks. That's what our customers are afraid of, and that's quite a challenge actually, to build very simple devices, very simple processes to attack those devices.